Right, so this is going to be our introduction to inverse trig functions. So when we're looking at an inverse trig function as opposed to a regular trig function, we'll be taking an input of some value off the unit circle and trying to figure out what angle that came from. So in that first example, I'm taking the sine inverse of the square root of 3 over 2. That's the same as asking the sine of what angle theta is equal to square root 3 over 2. We know from the unit circle that pi over 3 corresponds to a sine value of root 3 over 2. So the solution there would be pi over 3. We can look at the same thing for each of the basic values for sine, cosine, and tangent. So in problem 2, we're taking the cosine inverse of root 3 over 2, which is the same as asking, or roughly the same as asking, the cosine of what angle is equal to root 3 over 2. And again, from the unit circle, we know that that value is pi over 6. And we can go through all of those values here in problems 1 through 12. We're going to start just by looking at taking the sine, cosine, and tangent inverse of positive values. That's problems 1 through 12. In addition to the notation of sine inverse or cosine inverse or tangent inverse, we also have these other notations listed down at the bottom, arc sine, arc cosine, and arc tangent. And those are just fancy ways of asking the same question. So arc sine is the same as sine inverse, arc cosine is the same as cosine inverse, and arc tan is the same as tangent inverse. Cool. So moving that into these circles here in the table, if we actually look at a full unit circle, we'd actually find two angles for any given unit circle value that would get us to whatever answer we were looking for. So since we can see it up here at the top, say if we look at problem 7, the sine inverse of 1/2, if we're just asking the question, the sine of what angle has a value of 1/2. So what angle has a sine value of 1/2? I could actually find two angles on the unit circle, one in the second quadrant and one in the first quadrant, right, where the sine is positive in both of those two quadrants, meaning that I could get either pi over 6 or 5 pi over 6, since both have a sine value of 1/2. But we want these inverse functions to be functions, which means I can only have one output. That is a necessity of a function, which means I'm going to have to make some restrictions on each of these inverse functions so that they only ever give exactly one output. So for sine inverse, where I've marked out the quadrants where it's positive and negative, I'm going to want to include one positive quadrant and one negative quadrant in its range. So for sine inverse, I'm going to pick the first quadrant and the fourth quadrant. In fact, for each of sine, cosine, and tangent, we're going to choose the first quadrant for all of our positive values. So it just ends up becoming a question of which quadrant do I want to choose for my negative values. So for sine inverse, I'm going to choose the first and the fourth quadrant. Also, sine inverse has a domain of -1 to 1, since I can only plug in numbers that I can get off the unit circle, and the unit circle is bounded by 1 and -1. So a domain of -1 to 1, and then a range of negative pi over 2 to positive pi over 2. So what I'm doing to get that range is that instead of taking the fourth quadrant as it's listed on the unit circle, I'm actually going to take its negative coterminal values so that my range can be continuous. So rather than having to go from 3 pi over 2 to 2 pi and then 0 to pi over 2, I don't want to have that awkward split in my range. So I'm instead just going to relabel that fourth quadrant to be its negative coterminal values and get my range that way. So over here on the right, you can see that I've calculated each of the negative coterminal angles for quadrant 4. So we'll be using negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2, specifically for the values, the points that we have memorized from the unit circle. We'll be using those. For cosine inverse, they're in the middle. Cosine is positive in quadrants 1 and 4, so it wouldn't make sense to use quadrants 1 and 4 for cosine inverse because I wouldn't be getting any of the negative values. But cosine is negative in the second quadrant, which makes that a pretty easy extension. So for cosine, we'll look at a range of 0 to pi. So we'll use the first and the second quadrant. We can just use the second quadrant as it already is, because it'll make a nice continuous range with cosine inverse. So just 0 to pi for that range, and the domain again is bounded by 1 and negative 1 because the unit circle is bounded by 1 and negative 1. On to tangent inverse. We're going to choose to use the same range as sine inverse because at both pi over 2 and at negative pi over 2, tangent is going to be undefined since tangent has a denominator of cosine, and pi over 2 and negative pi over 2 are where cosine is 0. So we don't want to divide by 0, meaning I don't want my range to go over that pi over 2 line. So even though tangent is also negative in the second quadrant, it might be tempting to use the first and the second quadrant like we did with cosine, but that would mean crossing an asymptote. We don't really want to do that. So it'll be a lot nicer to use that same range of negative pi over 2 to positive pi over 2, meaning we're going to be using those negative coterminal angles again for tangent inverse. But going off the point from a moment ago, where tangent is undefined at pi over 2 and negative pi over 2, I'm going to use open parentheses on the range because I don't want to include either of those values in the range of tangent inverse, which is the slight difference from sine inverse. But also the domain of the tangent inverse function is going to be all real numbers, since I can get any number out of a tangent function. I can always find an angle that'll get me any tangent value, meaning the domain of an inverse tangent function is all real numbers. So let's apply what we just talked about there to the negative values off of the unit circle. All right, so to get the sine inverse of negative root 3 over 2, it means I'm going to the fourth quadrant, but again, I want the relabeled fourth quadrant that has negative angle values. So I know that the sine inverse of 3 pi over root 3 over 2 would be pi over 3, meaning the sine inverse of negative root 3 over 2 is negative pi over 3. So for the sine inverse of negative root 2 over 2, what angle has a sine value of negative root 2 over 2? I know that that's going to be a pi over 4 class of angle, and I want the one that's in the negative fourth quadrant, so negative pi over 4. We get the sine inverse of negative 1/2. That'll be negative pi over 6. And the arc sine of negative 1, which is the same as sine inverse of negative 1, that's going to be negative pi over 2. And then we'll go get the cosine values. And again, we're looking at all of the negative values here. So we're going to do the cosine inverse of each negative value. And so for cosine, I'm going to be looking into that second quadrant. So I need an angle with a cosine value of negative root 3 over 2. That should be 5 pi over 6. So that'll be in the second quadrant. Next, I want an angle with a cosine value of negative root 2 over 2, which must be 3 pi over 4. An angle with a cosine value of negative 1/2, looks like 2 pi over 3. And the arc cosine of negative 1, same as the cosine inverse of negative 1, that'll be at pi. Then get those tangent values. The tangent inverse of negative root 3, So I'm looking for an angle with a tangent value of -√3. Now there's only one 3 in the value, so there should be only one 3 in the angle. So this is -π/3. Next, I want an angle with a tangent value of -√3/3. This time, 2 3's in the value, so 2 3's in the angle. This must be -π/6. Tangent inverse of -1 is going to be -π/4. And then since tangent inverse of -0 would be the same as tangent inverse of +0, I decided to include one more inverse sine function. So I want the arc sine of 0, which also happens at 0. Meaning the only unit circle value that wasn't covered was the inverse cosine of 0. But that'll happen at π/2.